All right, so we are in Algebra 1, Lesson 3-9, Word Problems Graphs. Today's date is Wednesday, October 21st, 2020. Our objective today is to do what? Ripley isn't here, so someone else is going to have to do it. Diego. Yep, so interpret and then make it. So again, if you pay attention to the units, they kind of give the problem away. So let's pay extra attention to our units. Example 1, who can read our prompt and the first question? Diego again. How long will it take? Or so the prompt is Mr. Brown, and then the question is how long will it take? So read both of those, please. How long will it take for Mr. Brown's beard to grow 8 inches? How fast will Mr. Brown's beard grow? There it is. Okay, so now we have this graph that we need to be able to look at. So I can see that the y-axis, the axis that's running up and down, is the beard length. The x-axis, the horizontal axis, is time in months. Okay, so this is an amount question. How long? What amount of time will it take for Mr. Brown to grow 8 inches? So that refers to a point. An amount is a point on the graph. It could be an x-intercept, it could be a y-intercept, but it's not going to be either of those in this case because 8 inches is not going to correspond to 0 time. Neither of the coordinates is 0. So everyone right now, try to point your finger to a point on this graph that represents 8 inches. And you need to be pointing somewhere on this line. You can either point here, 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 here. Somewhere on this line, point your finger to 8 inches. Where is 8 inches? Or maybe you can circle with your pencil. Now, I know it's kind of hard because of being 6 feet apart, but try to look over at your neighbor's paper. Did they circle the point that you circled? Or did they point to the same? I know. So here's the giveaway. So I'm talking about inches. Inches, I'm paying attention to my units. Inches is the vertical axis, the y-axis, the up and down axis. So I find 8. 8 over here is 8 right here, and I come out, and I maybe can zoom in so you guys can see this a little bit better. If I start at 8 and then I just come out and intersect this line, it intersects at this point right here. Everyone should have that point marked on your graph. And then go down. You have to figure out, okay, well, what time does that correspond to? If you come all the way down, it corresponds to 14. And our units for 14 is months. It'll take Mr. Brown 14 months to have a beard that's 8 inches long. And I believe I made that problem like pretty accurate. I just Googled the average hair growth. I mean, it varies from person to person. Maybe we should go ask Mr. Brown when he comes in at the end of the period how fast his beard grows. So our answer here is 14 months. I think I'll leave the lines on here so that people can see them for the notes later. Shrink right there and right there. All right, next question. How fast is Mr. Brown's beard growing? One person has his hand raised. 2 people. Jose, go for it. 1 inch every 2 months. How'd you come up with that?
When it goes up 1, it goes right.
Yeah, so it goes up 1, so plus 1 in the y direction. I guess I can make my numbers a little bit bigger. Plus 1, and then when I move to this point from our initial point to our next point, I moved 2 units to the right, so plus 2. All right, yeah, thank you. So let me come over here and label what Jose said. Jose said 1 inch per 2 months. And notice that this problem doesn't say how long does it take or how much how many inches does Mr. Brown's beard grow per 1 month? It didn't say that. It just said how fast. And this is a speed, 1 inch per month. It's a very slow speed because hair growth, but that's the answer. We don't need to do anything else to it. If you needed to convert this to just something with 1 month, how would you do it though? There are problems that do ask that, like how fast does he grow per 1 month? What would you have to do to adjust this slope? Yeah, Zeke.
Divide each one by 2.
Yeah, so I could divide both of these by 2 if I wanted to, and that would be 0.5 inches per 1 month. But either of these answers are fine. You can do the yellow or the green. I want to quickly Google how fast does hair grow? And hey, check it out. The American Academy of Dermatology says that the hair grows about 1/2 inch per month on average. So that's a pretty accurate number. So that means if you have 6 inches of hair, that's a year's worth of hair. So I don't have 6. So if you're a girl, you can pull it out and measure 6 inches and be like, that's a year, right? Or maybe, yeah, if you have awesome hair, then you can do it too. All right. Example number 2. Charles. Who wants to read about Charles? Read the questions, read the prompt, read all the text there. Sorry, Diego, you have to give it to someone else. You do have a beautiful voice. I need to hear someone else's beautiful voice. Someone else. This is your chance to participate. Yeah, Haiti. Yeah, good question. And again, I did base this. I just looked at the Wikipedia article for June Mountain, June Lake. And June Mountain does have an elevation that is roughly 2,500 feet above June Lake. So these are accurate problems. I tried to be at least. Yeah. So when? One hand. Anyone else have an idea? When will Charles arrive at June Lake? Just by interpreting that graph. 2 people, 3 people have a hand. 4 people have a hand up. Giorgio.
23 minutes.
How'd you get that?
The bottom, the end of the line is at 23 minutes. Well, it's roughly 23 minutes.
Bottom of the line. Are you talking about this end over here?
Yes.
Okay, so is it a point on the graph? This point on the graph?
Yes.
I agree that that point looks between 22 and 24, so that's 23. Why is that point the point at which Charles arrives at June Lake?
Because it's 0. Okay. Like
What is 0?
the x-intercept.
It is an x-intercept, which means what is 0? Is it the time or is it the altitude?
Time. No.
Altitude. And if altitude is 0, ignore the question. If I say my altitude is, let me take out my phone so I don't break it. If my altitude is a foot off the ground and now I'm 0, 0 altitude means I am on the ground, which is what we're asking for. Exactly. All right, there we go. Thank you. So yes, everyone write down. Answer is 23 minutes. Because that's when our altitude is 0. If we are 0 meters above June Lake, we are touching June Lake. Maybe we're at -5 because we plunged in the water, right? All right, next question. How much taller is June Mountain compared to June Lake? Raise your hand once you think you have an answer. Again, how much taller is June Mountain compared to June Lake? Let's zoom in on this graph. One person has his hand raised. Oh, yes, yeah, that was you. 2 people have their hand raised. 3 people have their hand raised. 4 people. Yeah, Braden. How'd you get that? The top of the, oh yeah, so like this thing right here. Okay, So I would agree. Yeah, in between 2400 and 2600, that's 2500. That's 2500. So you're correct. Can you explain why that's the answer?
Because that's where the graph, ends at the top.
Okay, yeah, you're probably gonna have to use words from the original problem. If you read Charles's hang gliding,
Oh, that's where Charles started.
it's re-
Right down to the.
okay, yeah. So it's where time is equal to 0. He hasn't started yet, and since he starts at the top, that must be the top. Yeah. All right. Thank you. Everyone, write it down. The answer here is 2300 or 2300, 2500, 2500 or 2500, however you want to pronounce this thing, feet. Let's see how well we follow that. Fists of 5 on example number 2. I'm getting 4s and 5s. No one's out of 3. All right, that's doing really good then. Thank you, Yesenia, for the 4. Let's move on to example number 3. Let's talk about Wyatt. I need someone to read. Another beautiful voice. Sorry, Diego. Ashley, yes. All right, so I think everyone understands the problem, but Wyatt's underwater. He's coming up to be able to breathe. We're okay with that scenario? He probably can breathe if he has like a scuba tank or something, right? Yeah, so this word right here, ascends, that is a fancy word that says he's going up. So if you want to ascend the stairs, that's a slightly pretentious way of saying I'm going up the stairs. But you can say I'm ascending the stairs, right? All right, so we're graphing these things. In the first half, they provided us graphs. On the second half, you need to make your own graph. You need to be comfortable with both of these because read the objective again. The objective is to interpret the graph. That was example 1, example 2, and graph, make a graph. That's example 3 and example 4. So how do we graph this thing? We need 2 points to make a graph, at least 2 points, or maybe a point and a slope. We need 2 pieces of information. So you guys need to be able to tell me what's your one piece of information that you found and how does that apply to the graph. Typically speaking, you're always going to start with a point. And then from that point, you can either find another point or from that point, you can find the slope to find another point. Either way, we're going to find 2 points. Does anyone see a point on this graph that we can graph right now? Yeah, Yesenia.
Is it like the 60?
Yep, he was 60 feet underwater. How do we use that to graph?
And then you go like on the time thing.
So time is this, I forgot to label it. Oh yeah, time is right there.
Down here. So he goes from 60, he goes up 1 foot every 2 seconds.
Wait, where do I start? At this 60? Which 60 am I starting at? This is the time that you said, right? Time 60?
At feet.
Oh, okay, so can you tell me what coordinate to go to?
The bottom.
Bottom, somewhere down here?
Yeah, like left. To like the 60.
Oh, okay, the y-intercept. So 0, comma, negative 60?
Yeah, because
Okay.
that's when he started to go up. And then so like every 2 seconds he's going up 1 foot. So it kind of like just, I don't know how to explain it, but like just like going up, going like 2 every, like, how do I say it? I don't know how to say it. It's like,
Okay, so I think you're saying like every 2 seconds, so I go like 2 in this direction, that's time, that's seconds, and then go 1 for every foot like that?
yeah.
Okay. So this is the most common mistake when we're graphing these problems. You are correct in thinking, yeah, go 2 right, 1 up, but look at
But
the units. They're not
the time is not exactly like 1, 2, like.
Exactly, yeah. So it doesn't say 1, 2, 3, it says 10, 20, 30. And not only that, our x-axis class is scaled differently than our y-axis. This x-axis, our time is every 10. Our y-axis is every 5. These are not scaled the same. Really, I have rectangles. If I need to think about a 10 by 10 or 10 by 10 square, there's my square. That square looks like a rectangle, right? Because this is not scaled correctly. Well, I mean, it's scaled correctly, but it's not scaled uniformly in both the x and the y dimensions. So we have to be careful about how to do this. Let me go ahead and write down our slope after I verified. Is everyone okay with this first point? Yesenia is saying 60 feet underwater. That's negative 60 feet. And that's where he starts. So if he starts there, that's at 0 seconds. 0 seconds on this x axis means I'm all the way to the left. I'm on this y axis. Give me a thumbs up. You're okay with this? Or nod your head vigorously? Okay. Okay, let's use our slope. So let's write down our definition for slope, because that's really what it's saying here. It's saying, hey, our slope is, we're going up 1 foot per every 2 seconds. And we get to change this slope to fit our graph. Question, Jose. Oh, yes.
Oh, yeah.
Sorry, what was the mistake? Oh, I keep making that mistake. This should be example number 4. Yeah, if anyone caught that before Jose did, log it. I see Yesenia with her hand up. I want to wait here. We're trying to, is it a question though? Or is it an answer? Okay, yeah, it's an answer. I'm trying to modify the slope so that one of these 2 units, 1 foot or 2 seconds, matches a unit that is listed here, so that it's one of these lattice points. So I want either to have my x, my change in x down here to be 10, or I want my change in y, this 1 foot, to be 5. How could I do one of those things? Again, we're trying to modify our slope so that we're obviously bigger, and then it matches one of these scalings. What do we multiply? We'll give it to Yesenia. Go for it.
You can multiply it, change the x to change time. Multiply them both by 5, and it's gonna give you 10 for the bottom, and then 5 for the top. But now you have like 10 seconds in time, and you can like do that.
So that means from this point, 10 seconds to the right is 1 hop over.
Yeah.
So that means plus 10, if I zoom in down here, plus 10 looks like this. Plus 10. Okay. And then plus 5, that's going, again, only up 1 hop. That's plus 5. Our new point is right there. All right. And this is the second hardest piece of information to kind of figure out. So we started with the fact that slope was 1 foot per 2 seconds. That was given to us in the problem. We multiplied that by 5 over 5. We need to multiply by something bigger so that it actually can fit on this graph. Why 5 over 5? Well, this unit is going up by units of 5. And then you can keep doing that over and over again. Yeah, Jose. Multiply by 20? Okay, yeah, let's do it. What happens if I multiply by 20? If I have 1 foot per 2 seconds, multiply top and bottom by 20, and you get what? Per 40 seconds. So that means if I started here, if I go 40 to the right, I come over here to 40, and then I go up 20. So from negative 60 all the way up to negative 40, and you get that point, right? Yeah, nice. And you can keep repeating this over and over again. You could keep repeating 20 feet to the 20 feet up, 40 feet or 40 seconds to the right. I could keep repeating 5 feet up, 10 seconds right. I can keep doing this over and over again. So I can keep making a bunch of these dots. And then there would be Jose's next dot if he was using that method. You can keep doing these dots over and over and over again until a clear pattern is happening here. I'm probably going to not do any more because I'm all done. Oh, let's just make one more. That's the last one anyway. And then I can actually finally graph a line that goes through these points. And I should probably make that line blue. It doesn't really matter. I'll just make it red randomly. This is a line that represents Wyatt ascending from scuba diving. And then I can ask questions about this graph too. I can ask you, well, how long did it take for him to get to the surface? And you can say, oh, well, the time, this axis right here, it happened at what, Braden? 120 seconds, which is how many minutes? 2 minutes, yeah. So it took him exactly 2 minutes to come up to the surface. Very nice, Braden. All right. Give me a fist of 5. How could you follow example 3? I'm getting 4s all around, universal 4s. All right. Oh, Yesenia's the only one with a 5. Good job, Yesenia. And Zeke? Okay, sorry. And Gio? Who's Gio? Oh, Giorgio? Okay. Do you like being called Gio or Giorgio more? What should I call you? Okay. No preference. Let's do example number 4, which we used to be example 3 again. I still need to go fix it. Okay, so Emma. Who wants to read about Emma? This is our last example for this whole unit. We're almost done, guys. Who wants to read about Emma? Braden, please. Thank you.
Emma's coming back from the volleyball game. The car is traveling at a constant 50 miles per hour and they arrive back at school after 4.5 hours. That's the distance between Emma's car and the school in miles and time in hours.
There it is. All right, so every single line is created by 2 points. It's a theorem in geometry once you hit that next year. Can anyone tell me what one of those 2 points is? I see Zeke has his hand raised. Anyone else? I'll give some more thinking time. I might call him Zeke. I don't know. We'll see. Just giving you time to think. We're given two numbers. I'm guessing one number is for 1 point. The other number is for the next point. We have 50 and we have 4.5. Somehow I'm going to use those 2 numbers to come up with 2 points. Well, 2 points will make a line, right? So somehow come up with 2 points. Yeah, Zeke, go for it.
So you have a point at 4.5 hours, 4.5.
4.5 hours.
It says that's how long. And then you can go up at 50 over 1 because that's 50 miles an hour.
Wait, I'm confused. Where's the first point? You said 4.5, but like, is 4.5 there? Like which 4.5?
4.50.
Oh, okay. So it's an x-intercept. So 4.5 comma 0. Why is that a point?
Because it says that they arrived back at the school after 4.5 hours.
Okay, so that means that the distance between the car and the school is 0 because it's at the school. Okay, I understand now. Okay.
And then because it's going at 50 miles an hour, you can backtrack it and go back up the graph at 50 over, negative 50 over negative 1, because if you're backtracking, that's the reverse of it, and you go up at an angle getting you to 225.
All right, so you said 50 miles per hour. You wanted to backtrack, so you multiplied the top and bottom by -1 to get negative 50 miles per negative 1 hour. And let's see here. So if you do that, did you do step by step? So you went like backwards 1 hour. You said like backwards 1 hour would give you 3.5. So that's -1. And then you have to go negative 50 miles. So that means that the distance is increasing, right?
Yeah.
So if I go up 50, 50 is right here. So come out to that point right there. And that means from there, I'm doing plus 50. And you keep doing that pattern over and over again. Yeah, Jose?
Well, I had a different thing.
Oh, okay, yeah, let's hear it.
Okay, so I thought 1 point wasn't 0, and the other point wasn't 1.550 or 50 or minutes.
Say that one more time. Sorry, I didn't understand.
So one point is gonna be on 0, and the other point is gonna be on 50 per, I don't know, distance, 50 on distance.
So,
Okay,
so 50 on
let me go,
distance.
right?
Yeah, point to the board.
The point is gonna be right there.
This point's gonna be right here.
Yeah.
Why?
Because it's going 50 miles an hour, right?
Yep.
And then 4.5, then 4.5 minutes.
Okay. So this point represents the fact that after 4.5 hours, I'm still 50 miles away from the school, though, right? Because this, yeah, if I'm just listing the point, this point corresponds to 50, which means I'm still 50 miles away from the school.
Oh,
And that point also represents when I'm 50 miles away from the school, that happens at 4.5 hours. Okay, yeah, so that's a way to interpret that point, but that isn't what's happening in this scenario, right? Because after 4.5 hours, I'm actually at the school. My distance between the school and the car should be 0. So this actually is not a correct point.
okay.
Yeah, I see Yesenia with your hand raised. Yeah, go for it, Yesenia. Uh-oh, are you frozen? No, I think I saw you blink. Can you hear me, Yesenia?
So what I did is like all different from like both of them. So I went to this 2 miles on 50, and then I went 2 to the right, and then on 1 on hours. So like the point is gonna be like right there.
You're right here.
Yeah. And
Okay.
then I went like 2 in hours and like 100 in miles.
Like that.
Yeah, and then I just like kept going like that all the way up. But like, is that right or no?
So you're really close. And I think this is probably one of the most common mistakes on this type of problem is you have the slope correct. It is still 50 miles per 1 hour because if you look at this point, yeah, 50 miles per 1 hour. You have the slope correct, but you don't have the intercept correct. The intercept over here is saying 4.5 hours is one of the intercepts, and you haven't used that information yet. So 4.5 hours is when you return to school, and it's hard to interpret that. I know for all of us that when I return to school, that means that my distance between the car and the school is 0. So that's the point that represents after 4.5 hours, I am back at the school. So slope is good, but the intercept was off for yours. So from here, you can keep doing Zeke's pattern over and over again, where you go 2 left, 2 up, or I guess really -1 hours and then 50 miles. But in terms of just counting the squares, it's left 2 up 2, left 2 up 2, left 2 up 2. And I can't go left 2 up 2, but I can simplify this to left 1 up 1, and it still follows the same line. So this is the correct answer. And then you can ask questions like, well, when they set off, like how far away were they from school? And just be like, oh, you interpret the graph. All right. That is the end of our last lesson for this unit. Let's come back up here to the objective. I guess I can do this. Our objective today was how well can you interpret a graph? That was the first half. And how well can you make a graph from these real world problems? Everyone give me a fist of 5 for this lesson. 4, 3, 5, 5, 4, 4, 4 for Yesenia, 4, and 3. All right. Any questions before we move on to the homework? All right, cool. Go ahead and write your summaries, you guys.